When we talk about composition of functions, we're going to be talking about this symbol quite a bit. This symbol, f, and then in parentheses g, and then in parentheses x. So there's two full sets of parentheses there. This is read f of g of x. That is what that symbol means in actual words, f of g of x. Basically, they're saying, look at the inside of this function. The inside is g of x. We're taking the g function and we're plugging the g function into the f function. This is basically substitution. So I'm going to try to use colors to make this a little bit more clear. I'll make f of x be 3x, and g of x is blue. That's 2x minus 6. We need to find f of g of x. And when I use colors like that, do you see how the blue is inside the green? Okay, now there's several ways to think about this. What I like to do is think about, we're taking in the green function, we're going to take the x out and we're going to put the entire 2x minus 6 in its place. We're going to take 2x minus 6 and substitute it for the x. So the green function is 3 times something. That something is going to be the 2x minus 6. We're taking the blue function and plugging it into the x of the green function. Now, once we do that, what do you think we're going to do with the 3? Distribute. 3 times 2x is 6x. 3 times negative 6 is negative 18. So f of g of x is 6x minus 18. Composition of functions is a way to take two functions and combine them to create a new function. Some uses of this are things like you get 10% off your purchase and you have a $200 off coupon or a $200 gift card. So combining those two things, you're creating this new function of a decreased price for the product and money off of your purchase. Number 10, it looks like there's a little bit of a typo. There's an extra f of x written here, so just cross off that first f of x. Ooh. F of x is x squared minus the square root of x plus 2. G of x is 4x plus 1. I will not give you one that looks this confusing on your own. But I think this is a good one to show you how that 4x plus 1 is going to go in place of the x. So our green function is something squared minus the square root of something plus 2. So if we are doing f of g of x, g is what's going into the f. F is like the skeleton that you're sticking that g into. Our g function is 4x plus 1, so we got 4x plus 1 squared minus the square root of 4x plus 1, and then plus 2. I should make you simplify this, like actually multiply this out, but I'm not going to give you one this challenging on your own, so we're just going to call this one done. Let's do an extra one. Okay, so my f of x is 2x plus 3. My g of x is 5x minus 2. We are doing f of g of x. So g is going inside the f. My f function is 2 times something plus 3. Instead of the x from that f function, we're putting the entire g function in its place. We're taking this g function and we are putting it in place of the x in the f function. So the 5x minus 2 would have to go inside those parentheses. Then we could distribute. This would be 10x minus 4 plus 3, which would simplify to 10x minus 1. Most of the time, our domain is all real numbers. (10x minus 1), that's a perfect example. 6x minus 18. There's nothing that would restrict what x couldn't be in those two examples. So both 6x minus 18 and 10x minus 1 would have the domain of all real numbers. You're looking for, if you have a denominator, then the bottom can't equal 0. We talked about that on the previous day's notes. So if you end up with an x on the bottom, then you have to think about what value would make that bottom equal 0, and x can't be that number. You have to also think about if there are square roots. So if you have square roots, then you want to make sure that the stuff under the square root is greater than 0. Because you can't take a square root of a negative number. Most of the time, our domain is all real numbers, but there are a couple of cases where, oh wait, x can't be something. We have to make sure we note that. Okay, so 11 through 14, and I'm going to let you try some of these on your own because some of them are review from the previous day. Your f function is x cubed. Your g function is x plus 4. I want you to do 12 and 13 on your own. This is a review from yesterday, Friday, whenever it was. Number 12, add the two functions together. Number 13, divide the functions and then think about the domain. What could x potentially not be? And then we'll do 11 and 14 together. Okay, and number 12, we do x cubed plus x plus 4. None of those are like terms. We can't combine any of them, so that's done. That's simplified. And that domain is all real numbers. Number 13, x cubed divided by x plus 4. This time we have a denominator, so our domain is x can't equal negative 4, because negative 4 is the x value that would make that bottom equal 0. Okay, we're going to do number 14 next. Number 14 is g of f of x. This time g is first. We're putting f of x into the g function. So since g is on the outside, that means we're doing something plus 4. And we're putting that f function inside there. And then see if there's anything that you can do to simplify. There's nothing in front of the parentheses. This is just x cubed plus 4. Then I want you to think about, are there any x values that we can't cube? Can we do positive numbers cubed? Yeah. Negative numbers cubed, 0 cubed, all fine. So our domain is all real numbers. Okay. Number 11. This is one of my favorites. F of x. This means we're taking that green function x cubed. We're doing something cubed. We're taking the f function and we're plugging it into itself. So what goes inside the parentheses is x cubed. Now there's parentheses, so we multiply those exponents. This becomes x to the 9th, and your domain is all real numbers. Next, we're going to evaluate with composition of functions. So our f function is 2x squared minus 7. Our g function is 5x plus 1. F of g of -3 means that we're going to start in the middle with that -3. We're going to plug -3 into the g function and see what answer we get. And then we'll put that answer into the f function. So start in the very center. We're going to start by doing g of -3. This is just evaluating that g function using the number -3. So it's 5 times -3 plus 1. What is 5 times -3? And -15 plus 1 is -14. Now we are going to do f of that number. Two times the -14 minus 7. And you can use your calculator to do this. 2 times -14 is -28, and -28 minus 7 is... Oh, shoot, did I forget the square? I forgot the square. That's my bad on that one. The parentheses are very important when you're entering this in your calculator, so I would do 2 parentheses, -14, close your parentheses, squared, minus 7. Our answer is 385. Now, a quick recap of what we did. We started here in the middle with -3. We plugged -3 into the g function and got an answer. Then we plugged that answer into the f function. So start in the middle, work your way out. In B, we are going to do g of f of 2. Starting in the middle, we're going to take 2, plug it into the f function, get an answer, plug that answer into the g function to get our final answer. It's basically like a 2-step process. So try that one on your own. So we take 2, we plug it into the f function. Don't forget the square because I like to forget squares apparently. And we get 1. Take 1, plug it into the g function, and you get 6. And that's your final answer. Example C is doing f of -5. So this means we take the f function and we do f of -5. Our f function is 2 times something squared minus 7. We're plugging that -5 in. So that's not what I wanted. 2 times -5, the parentheses are important, minus 7 is 43. So my first answer, is 43. So we did this part, f of -5, and got 43. Now we need to do f of 43. And should you be surprised if you get a huge number? No, because you're squaring 43. 3,691. This last problem on our notes we aren't going to actually do, but it's kind of a more real-world composition of functions type of situation. So you have a coupon for $150 off a new TV. When you arrive at the store, you find that all TVs are on sale for 30% off. So does it make more sense to use your discount, then take 30% off, or does it make more sense to take 30% off, then use your discount? Because one of the things that we didn't talk about here is that f of g of x is not the same as g of f of x. The order that you plug those functions into each other really matters, and it creates different functions. So the order is important. That's really what I want to get at with that.